This will be our last video doing factorization of quadratics. We'll be looking at two special cases. And here's 8 questions there. The first 4 are one type and the last 4 are another type. Now after this video we'll be getting into solving quadratic equations for every occasion. Doesn't matter if they have whole numbers, if they're nice and easy. And in fact I'll be able to solve these type as well. But this is the last type that we're going to be able to do really quickly in our head. And all of these can be done in one line. I'll leave all this space here and I'll just write the answers down. But first, let me discuss the two types here. The first type is something x squared plus something x. That's what all these types are going to look like. And I won't bother leaving these boxes here, but that's what every single one of these are. So it's a 7 and it's a minus 3. It's a 4 and a plus 3. It's a minus 5 and a 1. 8 and a 2. They all look like this. So let me, instead of those boxes, it's much more correct to use letters. Ax squared plus bx. They all look like this. Now here's the trick. You know what, instead of A and B actually, because that confuses some students, you really need to get used to using letters instead of numbers. But for now, I don't think it's that important. Let me do the first question as the example. The secret here is to notice that both terms have an x. It might be a little easier if I rewrite this. Remember what this is. This is 7 multiplied by x minus 3 multiplied by x. That's what that is. That's what x squared means. It's just 2 x's multiplied together. Now, if we look at it like that, we can see that 2 of the terms have an x. And we've already used to adding 3x plus 4x. We've even got used to adding ax plus bx. So no different here to add 7x plus minus 3x. And that will become 7x, well, plus minus 3 is minus 3 x's. That's the only secret here. We take an x out of this and an x out of this. Can't throw it away. It didn't disappear anywhere. We just leave it outside the bracket. And of course, we multiply this back in. X by 7x is x squared. X by minus 3 is minus 3x. So that's the answer to all of these. We take, I'll write it a different way than I did there. We'll take x out and 7x is still left. Minus 3 is still left. Pause the video now and see if you can do all 3 of these. You can take as long as you want, but if you have it, if you know it, you should be able to do it very quickly. Okay, so I'm just going to jot down the answers while saying some things about them. This one both has x in both of them. X leaves a 4, leaves an x, and leaves a 3. There's going to be a little trick to the fourth one. But this one here has an x in both of them. What's that? That's a minus 5x and a 1. If I take an x away, there's the 1 left that's in front of it. This, of course, I could write a little different. It doesn't make any difference, but it's 1 minus 5x. We tend to write the minus second. Just looks a little neater. Doesn't matter. It was perfectly correct the other way. Okay, the last one. I only have one line, so I'm going to have to do this both in one go. There's an x here, and there's an x here. But there's something else in both of those numbers. There's a 2 in this one. There's a 2 in this one. 2 4s. 8 is made up of 2 4s. So there's a 2 here, 2 1s, and a 2 here, 2 4s. So if I take the 2x out, take an x out, left with x. Take the 2 out of 4, out of 8, I'm left with 4x. Plus 1. If I take 2x, divide it out, I'm left with 1. So let's just double check our work here. 2x by 4x is 8x squared. 2x by 1 is 2x. Perfect. Remember why we're doing all this. We now have two things multiplying. That is really helpful when we do something like equal 0. It's really easy to solve. Actually, in all of these questions, if they equal 0, x would equal 0. Or 7x minus 3 would equal 0. So the answer would be x is 0, or x is 3/7, 3/4, or 0. The answer would be, oh, I have it switched around now. It would be minus 1/5 or 0. Plus 1, sorry, this one should be a minus. Sorry, this one should have been a minus, and this one here should be a minus. This one is also a minus, sorry, minus 1/4 and 0. So it makes it very easy to solve all these questions. That's it, there's no real trick to this. This should be something you should do quite quickly and quite naturally. It's really just taking one multiple out. You should be happy to take the 2 out of this, but you also should be happy to take the x out. If you have any questions, let me know in the comments and I'll be happy to help. Let's see, let's do a bit of work here. This one's a little more complicated. This is missing the x part, so we have, I like the boxes, I guess. Something x squared plus, we used to have something x plus something. We're just missing this part this time. And again, we don't like using the boxes now that we're a little older and wiser. We use A and B. So we have something with the x squared coefficient and then something with the number. Okay, so that's what we're looking at here. I have a plus here, but all my questions will have a minus. Plus is really hard to solve. Sorry, B should be here. Too many pluses. So all of these B's, in fact, are minus numbers. So let's, again, instead of using A and B, which we can use, we should be able to use going forward at least. For now, I will give you a bit of a break and we'll use the first one. X squared minus 4. Okay, so how we're going to factorize this is really, we're going to rely on being shown a trick. Now there is another way to do it, but, well, sorry, there's a way to do it when it equals 0 that we won't need to factorize so much. So remember, all of these are really helpful when it equals 0. Whereas this one, it's not as necessary, but this is a really useful identity. So basically this appears all the time in maths. Lots of times. So it's a really useful thing for us to keep an eye on. You know what? Instead of using the first one as an example, it'll be much more useful for me to use letters. But I'll actually use more letters than usual. I'll use A squared. I could use A, but it just looks easier when I use it like this. A squared x squared minus B squared. Now all of these actually look like this. I know it doesn't seem like it, but there's a 1 here. 1 is 1 squared. It's the same thing. So we have 1 squared x squared minus B squared. 2 squared. 3 squared. 1 squared. This one's a little harder, but it's square root of 7 squared. Everything can have a square root. So all of these actually look like this. So basically the identity we're going to learn is, it's really useful. We're going to learn, well, I'm going to show it to you, and then I'm going to prove to you that it is in fact correct. I of course didn't invent this. I'm sure it was hundreds of years ago. But I will show you that it is correct and show you how to use it. So the answer to a question that looks like this, which is all of the ones we're going to do, is ax plus b, ax minus b. The answer is always going to look like that. And I'll prove to you that I'm correct by just simply by multiplying everything out. I will get a squared, a by a is a squared, x by x is x squared, ax squared. Ax by minus b is minus abx. A, b, and x, they're all there. B by ax is plus abx. I can put these in any order I want, okay? If you're worried that it should be bax instead of abx, same thing. 2 multiplied by 3 is the same as 3 multiplied by 2. Okay, and the last one, b by minus b is minus b squared. This is equal to this, isn't it? They're the same thing. 8 minus 8, 0. 7 minus 7, 0. A million minus a million, 0. Any number minus itself, 0. I won't rub it out, I'll leave it there. Ax squared minus b squared. What I started with. So what I'm saying, and this is the proof here, is that if you start with this, let me try to rub this out. I'm going to destroy it all. So if you start with this, you will finish with ax minus b, ax plus b. I'm sorry, did I have that the other way around? I'm not sure, but it's the same thing. Again, 2 multiplied by 3 is the same as 3 multiplied by 2. You can move them around. If you're given a question that looks like this, that is the answer. If you're given a question that looks like this, this is the answer. The square root of the number in front of that, which is 1, which is still 1, x. So basically, 1 squared is in front of this. So therefore, 1x, which is just x. The number here is 4. 4 is b squared. B must be 2 then. This must be 2. Plus and minus. I'm not sure if that was so clear. Have a look at the others yourself. See if you can do them. I will do them now in a minute. Basically, this is what I'm saying. Square root of the first one is x. Square root of the second one. What could b squared possibly be? Well, sorry, b squared is 9. What could b be? That's awkward to say. What number is b if b squared is 9? Well, it must be 3. For those of you who are wondering, what if it's minus 3? Yeah, it could be. So it's plus 3 or minus 3. Or maybe it's plus minus 3 and minus 3. It's going to be the same thing. It's going to work out the same thing. Write it down yourself if you don't believe me. Now here we get to an interesting one. In this case, A is not 1. A is 1. A is 1. A is 4 now. Okay. Well then, A squared is 4. In that case, A must be 2. In this case, B squared is 1. In that case, B must be 1. Last one. Actually, you know what? I'm going to do another one. Number 9 is, how about 9x squared minus 16? This one here, what about a squared is 1? A must be 1. B squared is 7. This is a hard one. B must be the square root of 7. Cannot do any better than that. Plus and minus. And very last one then. A squared is 9. Well, A must be 3. X is always there. B squared is 16. B must be 4. If B squared is 16, what multiplies by itself to make 16? Must be 4. What multiplies by itself to make 9? Must be 3. What multiplies by itself to make 7? Square root of 7. Square root of 7, square root could be used all the way here. You could just write square root of 1 square root of 4, square root of 1, square root of 4, square root of 1, square root of 9, square root of 1, square root of 9. It's just we know the answer to a lot of them. That's all. Okay, well that's it. That's the last two special types of factorizations. We're able to do all the simple quadratics now, basically. All the simple quadratics, and they come up a lot, so it is useful to know how to do them very fast. But as of the next video, actually, you know what? I'm going to do a really short next video on surds, on square roots. Just it'll only be 3 or 4 minutes, hopefully. But after that, we will get right into completing the square and the quadratic formula. We will learn how to solve every quadratic once, actually nearly every. We'll have to wait another few months until we're able to do every one of them. But we'll be able to do all real quadratics. That's an interesting term because we'll then learn how to do complex, or sometimes called imaginary ones. But until then, have a good time and I'll see you. Bye.